My name's Bethan. I'm a partner innovation engineer at Confluent. I work alongside Niamh here. And in this session, we're going to talk a bit about simplifying Apache Kafka through our configurations for producer and consumer, our client applications. So, first of all, I'm going to do a basic overview on client applications and then introduce the Kafka Client Builder library that we've been working on to simplify those configurations. Niamh's going to take us through that in a bit more detail with some demos of our producers and consumers in action. And then hopefully we'll have time for questions at the end. So, client applications. You'll probably hear it said a lot. They're the foundations for Apache Kafka. That is how we're going to get our data into and out of Kafka, starting with the producer, which is the application that you create to write data to a topic in Kafka. That data is in the form of events, something that's happened. Could be clicks on a web page, could be inventory, card transaction, anything. It's a piece of data that you want to store, share, or process using Kafka. And you'll write your application to send that data to the topic that sits in the Kafka broker or brokers. And your topic you can think of as a log of similar pieces of data. In Kafka, we often talk about it as a message or a record, that the core of which is a key value pair, where your key identifies the data in some way, and the value is that important business data that you want to store. Then we move on to the consumer, which will pull the topic to request those messages that have been stored in the topic, kind of the log. And you could have multiple consumer applications. That's how you would scale horizontally. They could all read from the same topic or one or more topics, and they would be grouped together in a consumer group. So that's how we're going to write to and read from Kafka. What might that look like in the real world? On your phone, you may have an app to order a pizza. You'll click to order. That app will send the order to a Kafka topic named pizza orders. And then your consumer application, that could be in the store, the restaurant, will request that order and get to cooking, and hopefully at the end of it, you'll get your pizza. Well, what happens if you haven't configured your producer correctly? Those orders might go a bit wrong. They might not get sent at all if it's missing vital information. Similarly, your consumer application in the kitchen might not be able to get any orders from Kafka. You won't be able to cook anything. Worst case scenario, it could all be configured incorrectly, nothing is working, and we'll find ourselves in the darkest timeline where nobody gets any pizza, and it's not a timeline I ever want to be in. Configuration is really important. And there are a few things that can make that difficult when you're new to Kafka. One aspect is Kafka is flexible by design. There are hundreds of configuration properties across your producers and consumers alone. This is really great. It means that you can tweak those parameters and optimize your application for whatever performance you need. If you need high throughput, low latency, there are configuration options that you can change to achieve that goal. And we want to do that. That's what we should be doing. Different use cases will have different business requirements, different business goals. You want to be able to optimize your application to meet those goals. Great. So what's the problem? There are hundreds of configuration properties across producers and consumers. Where do you start? Some of those properties you may never want to touch. You should just leave them well enough alone. They're doing their thing. You can trust that they're doing that in the background. The default will be fine. Some of those properties are essential. Without them, you're not getting data anywhere. And some of those properties will have a real effect on your application performance. You may want to change just a few of them, and perhaps changing one property may have an effect on another property. How do you know that combination? It can take a lot of time to research this, a lot of effort, and a lot of knowledge that you'd rather be investing in other aspects of your application and some of the cool functionality you're going to write. So that's why we looked into creating a library in Java, the Kafka Client Builder library, which is designed to be used with Kafka on-prem and in the cloud. And the idea behind this library was to do some of the configuration for you. Where possible, could we pre-configure some of those settings? Could we minimize some of the hassle that goes into setting up your client applications? I think the best way to cover that is to show you some of it. Let's go back to our producer right at the start that's writing and sending our data to our Kafka topic. This is what an Apache Kafka producer in Java might look like now. Quite simple version. You've got your producer config properties map, where you're giving your property key and value. You'll notice here, bootstrap servers, really important. We need to know where our Kafka brokers are so that we can send our messages there. I'm going to point out as well the key serializer and the value serializer. You can see here we've specified string serializers from a Kafka library. And these are essential for letting your application know what format your message data is in. And your key and your value might be different. In this case, they're both strings. Without that, Kafka won't be able to convert your data into raw bytes so that it can be sent to the Kafka topic where it will be stored as a byte array. Similarly, in a consumer, it needs to have deserializers specified so that it can convert those byte arrays back into the data format that you want to consume and process. Then you'll see we're passing that producer config into our Kafka producer and instantiating it. This is using the client API for Kafka, the Java API available for producers, and there's one for consumers as well. It simplifies things a bit. We've got a topic, demo topic here, and a simple loop that's looping through, giving us our key and value for our message. We'll use those along with the topic to create a producer record and send that to Kafka. At the end, we're just going to flush and close the producer. This is what that same configuration looks like with the Kafka Client Builder library. Bit similar, some things are a little different. We're using a builder pattern to make it easy to read and clean and easy to set up. You'll see we've got our bootstrap servers again. We've got our topic. You won't see us setting up the message, but it's in our supplier here, the message supplier, cleverly named. And I'm just going to talk a little bit about that now. If you're not familiar with the supplier, it's a functional interface in Java that has a single get method that we're using to return a producer message with our key value pair. So there's a little example here on the side that's generating some really meaningful data, a random number and a random string. But you get the gist. This is returning as a producer message. Every time we call get, we'll get the next message until there aren't any more, or you choose to close it down. You'll write the supplier. It'll be as simple or as complex as you need it to be. It's up to you. This is obviously a fairly simple implementation, but Neve's going to show us in the demo later how you could use that to do an HTTP request and create your key and value from that. Going back to that pre-configured producer, you'll see bootstrap topic supplier. We just build it and send. And it'll keep sending until we have no more messages to send or we choose to shut it down. It'll auto-close, auto-flush, and auto-close. But there's one more thing I want to point out here that you may have already noticed. Something a minute ago I said was incredibly important that we don't have here. Key and value serializers. As I said before, whoa. Sorry. Apologies. as I said before, the key and value serializer are really important for converting your message into a byte array and converting it back into the data format at the end. If you've created a client application before and have not specified your serializers or have selected the wrong one out of the many options available, you'll know what happens next. We're going to get a lot of error messages. So why don't we have those specified? The Kafka client builder does it for you. You can choose to add them if you want. If you know what serializers you're already going to use, you can put them into the builder, off you go, perfect. But you don't have to. The Kafka client builder is using another library, another Java library called the Smart Cerdes library. This identifies the data type based on the contents of the data stream. And it has a number of supported data types from primitive, schema, and schemaless. To touch on it briefly, how that works, it uses a number of methods to check where it can identify the data type. For example, is it available in the headers? Can you tell from the length of the bytes? Is there a schema ID or schema registry details present where it can get a schema type from there? And ultimately, it will assign the data type to your message headers for you. So that's some of the initial features I wanted to talk about. I'm going to pass it over to Niamh here to go into a bit more detail and demo that for you.
Thank you very much, Bethan. Now I'm going to cover the producer. So initially, we're going to look at some configuration. Then I'm going to do a comparison of the Apache Kafka producer to a producer using our Kafka client builder library. Then we're going to have a look at some profiles. And finally, we will end with the producer topic with a demo. So let's go back to the start. So this is where our producer sits. Our producer has events, and inside these events, we have our headers, which are optional, and we have our key and our value. The event is published to our Kafka topic. And now we're going to have a look at our pre-configured producer in the Kafka client library. So as Bethan showed before, we create our Confluent Kafka producer. It's wrapped in a tray with resources. So once we have finished sending, it's automatically closed and flushed. We have our bootstrap server, our topic name, and we pass through our message supplier. We call build, and it's as easy as that. The configuration is extremely flexible. It's not just the configuration that you see on screen. There are multiple options that you can pass through with our builder pattern. You can see here, for some examples, we have added the compression type to be snappy. We have added additional config. So if there's anything through the builder that we haven't added, you're more than welcome to create a hash map and pass that through. We here have a callback, and inside that callback, we log if the message is sent successfully, and we also log if there's any errors. You don't have to log. You can do whatever you want. If there's an error, you can send that message possibly to a dead letter topic, which we will cover later. It's up to yourselves. So when we were thinking about how we could make producing and consuming easier for the user, we didn't just end with creating the builder pattern and saying, off you go. That's enough configuration for today. We took a step back and we said, how can we make it easier for people to produce and consume with different profiles? For every scenario is completely different. So we started off with our default producer. That is your starting point. It's got the least amount of configuration set by ourselves, and this is what it looks like. So it looks quite similar. You've seen it a couple of times today. Very minimal, and this is all that you need to be able to send messages to your Kafka topic. Then we thought of our high-throughput scenario. So this is aimed at video streaming and stock markets. This is what a high-throughput producer would look like today with Apache Kafka. You have to set a lot of the producer configuration, which you've also had to research. And believe me, there is not one place on the internet where you can just search high-throughput producer and it gives you that configuration. We have had to gather multiple sources together and come up with what we believe is the best configuration for a high-throughput producer. You'll notice you also have to provide the key serializer and the value serializer. You then pass this configuration through your Kafka producer, you create your producer record, and you call send. But with our high throughput producer, using the Kafka client builder, it's as easy as adding .with producer profile, high throughput. All of that configuration is set in the background, and immediately you're using a high throughput producer that also is using the smart Cerdaze repo to be able to serialize your event, your message. And finally, we have our low latency producer, and that's aimed at fraud detection and real-time inventory management. You can see, again, it's quite a significant amount of configuration for the producer. Then we have to pass through our Bootstrap server, our key serializer, our value serializer. We then create our Kafka producer, pass through all of that configuration that we've had to spend time researching and deciding if it's right for our situation. And then we create our producer record, we call send, and ultimately we call close. But with our pre-configured low latency producer, it's as easy as adding .with producer profile, low latency. Now, any of the configuration that we have set in the background is not the configuration that you're stuck with, because everybody's situation is different. Everybody's need for a low latency producer really is unique. So with the builder pattern, any configuration that you would set through here in the code is automatically automatically overrides our configuration. So if you need to do some tweaks, work away, that is completely available to you, but we believe this is your best starting point for a low latency producer. And now let's have a look at a low latency producer demo. So you can see here we have our shutdown latch for some thread execution behavior. We have our application.properties. This is where we will load some of our properties like our Bootstrap server, our topic name, etc. Then we create our Confluent Kafka producer using the builder pattern. We pass through those required properties. Our topic name here is our pizza orders topic, and we'll have a look at it in Confluent Cloud. So you can see we have pizza orders. We have no messages at the moment. There is no schema attached. And now I will go back to the code, and you will see then we have our supplier, and that's where we're going to get our messages to be able to produce into our Kafka topic. So we have a look at our pizza order supplier. Again, we have some properties that we'll load in. And then ultimately what we want to do here is we want to set up some of the connections to be able to generate the pizza orders, random pizza order data, and then we will create our key value pair, which will be returned in a producer message, which will then be sent by our Kafka producer to our topic in Confluent Cloud. We're using our high throughput profile, and then we have some SASL configuration for to be able to connect to our Confluent Cloud cluster, and then we have some schema registry properties that are required. And then finally, we have our callback. So we will log if there's any errors, but we will also log if we have successfully sent our message to our topic. We then have to call build. And finally, we will send, and then we clean up the shutdown latch, the thread execution. So we will run this, and we will see some data, hopefully, go onto our Kafka topic. And there we go, successfully sent messages to our topic, which is pizza orders. So now if we go and have a look in Confluent Cloud, you will see if we go to the messages tab, some of those messages coming in. It just takes us a couple of seconds just to load, and there. Already we've got some messages of random data, so you can see the date, status was accepted, the order lines, whether or not they've ordered pizzas, sides, the product ID, the unit price, etc. You'll see our key and our headers. So using the Cerdaze library, it's automatically detected that the key was a string and the value was our JSON schema. And now if we go to our schema, because we passed through our schema registry URL in the producer properties, you can see that it's automatically created the schema for us. And there's some other, you can get desserts possibly with your pizza, calzone. The data is not just limited to pizzas. now let's have a look at our consumer. So first we're going to start with our configuration. Then we're going to have a comparison of our Apache Kafka consumer to our Kafka client consumer. Then we're going to look at some profiles, and we'll finish with a demo. So you can see we have our consumer at the end of the process. It consumes those events that we have published to our Kafka topic. So it pulls from the topic to get those events. And this is what an Apache Kafka's consumer probably is familiar with. It's a lot of configuration. You have to then create your consumer, you subscribe to a topic, you then have to create your consumer records, and you poll. And in this example, we just log every message that we're polling from our topic. And this is what it looks like with our pre-configured Kafka client consumer. It's a lot nicer. It's far less code. It's quick and easy to set up. You create your Confluent Kafka consumer. You have your group ID, your bootstrap server, your topic name. You call build, and then finally you call poll. And again, we just log out our result. And just like the producer, the configuration is completely flexible. You can add in some SASL config. There you can see there's a lot more configuration that you can add through the builder. Again, if there's any configuration that we haven't set through the builder, you can pass through an additional config map, and the consumer will take that configuration and it will be used. We also created the same three profiles. So first, let's have a look at our consumer default profile. And that's exactly what it looks like. It's just what you've seen before. This is ideally it's aimed towards the starting point of your consumer. It's the least amount of configuration set by ourselves, and it is the most configurable. We kind of see this as possibly if you're going to use like a POC, so you don't know or you don't necessarily know all of the configuration that you need for right now, and you don't want to create a consumer with a lot of configuration and have to spend time later on coming back and editing that configuration. You can quickly consume and then come back later on and add in the configuration that you need. And next we have our high-throughput profile, which is aimed towards log aggregation and analysis, as well as data warehousing. So you can see this is what an Apache Kafka consumer looks like at the minute. Again, a lot of properties you need to set for it to be a high-throughput consumer. You then pass through those properties, create your Kafka consumer. You then subscribe to your topic, and ultimately you call poll. But with our pre-configured high-throughput consumer using the Kafka Client Builder library, it's as easy as passing that with consumer profile, high-throughput, and the configuration that we have set in the background through a lot of research will be automatically used. And just like any other profile, if any of the configuration that you want to edit, you can set that through the builder that will automatically take that configuration and it will override the configuration that we've set. And finally, we have our low latency profile, which is aimed towards online gaming and IoT devices. And this is what it would look like with Apache Kafka. Again, a lot of configuration. You then have to pass that configuration through. You have to subscribe to your topic, and then you can call poll. But with our low latency consumer, it's as easy as passing that with consumer profile, low latency, and immediately you're consuming with the low latency configuration that we have set. And now let's have a look at the demo. What's important to note is that I used a high throughput producer and I'm using a low latency consumer. You can mix and match the profiles, so you're not stuck to one profile if you decide that one of them fits your producer scenario better than your consumer scenario. So here we have our countdown latch. Then we have our application.properties. And here we have put in our group ID, our bootstrap server, and our topic name. We also have our dead letter topic, and this is where we'll store any messages that couldn't be processed. And we'll have a look at it in Confluent Cloud in just a second. There you go. So we'll see in our topics, it's just underscore DLT. So it's got the same original topic name. Then we have our low latency profile. We have some configuration that we need to be able to connect to Confluent Cloud. If you're not connecting to Confluent Cloud, you won't need this configuration. So your consumer will be a lot less. Then we have our schema registry, URL, username, and password. We call poll, and again, we just log whenever we're consuming the message from our Kafka topic. And finally, we just await for the shutdown latch just to close everything up once the consumer is finished consuming. So if we run this, there's some configuration logging, and then immediately you can see that we are consuming from our pizza orders topic. We have some pizzas, pizza order ID, we have our unit price, we have if it's a pizza or a dessert, and so on. So all of the same data that we had seen whenever we were looking in Confluent Cloud for our producer. And again, it's important to note that because we're using the serialization and deserializer library, we have never set the type for the deserialization in the consumer. It automatically uses that library to be able to figure all that data out and consume correctly. You can specify the deserializer if you wish. We have added those fields through the builder, but I think we would prefer that you use the smart CertS because we think it's pretty cool. Oops. Yeah, so now we're just going to do a profile summary. So we have our default profile. That's our starting point. Least configuration set by ourselves. It's the most configurable by yourselves from an initial starting point. Then we have our high throughput, which is aimed at video streaming, stock markets, log aggregation, and data warehousing. And we have low latency, which is for fraud detection, real-time inventory management, online gaming, and IoT. The examples we give here for each of the profiles, they're not set in stone. It's just down to your use case. We're giving people an idea of what they might want to use the profiles for. And now I'm going to hand it over to Bethan to talk about the summary.
Thanks, Niamh. So hopefully you've seen through the demos there, the aim of the library was to maintain all the flexibility that we talked about earlier with Kafka that makes it so useful for your applications for whatever kind of performance you want to prioritize. It's not too dissimilar to Kafka before, but is hopefully a bit easier to set up, a little easier to read, intuitive, and it won't take so much time to research all those settings yourself. In just a few lines of code, you can get up and go. So, final note, it's coming soon. We have released it internally to Confluent staff for some feedback and are in the process of releasing it publicly, open source, so it'll be available should you wish to use it. There's a QR code there. If you're interested in either library, that's the Kafka Client Builder or the Kafka Client Smart CertS, if you want to fill in that form, we'll use it to send you just a one-time email when those become publicly available. And with that, thank you very much for listening. Hopefully we have some time for questions at the end, Maria.